Okay, so now let's do a problem in maximum power transfer theorem. Okay, so here the question is, find the impedance ZL so that maximum power can be transferred to it in the network. Find the maximum power. Okay, this is the question. So here in this question, this is how normally the question they will ask. Okay, that's they'll give you a circuit and they will show you the load impedance and they will ask you to find the value of the load impedance such that maximum power can be transferred from the source. And then also they will also ask you to find the maximum power. Okay, so this is how usually the question will be asked. So like I said before, you just need to treat this like a Thevenin's voltage problem. Okay, so first what you do is you consider this as a Thevenin's voltage, Thevenin's equivalent. So which means you need to remove, which means you need to find VTH and ZTH, right? We need to find both the Thevenin's voltage and Thevenin's impedance. So you remove the load and you apply VTH over here. Okay, so let's do that. So first I will find VTH. Okay, so to find VTH, what I do is in this circuit this is the load, so I will remove the load. Okay, and the voltage across that open voltage across that will be VTH. So this problem is basically the same like doing the Thevenin's voltage. Okay, that is both for Thevenin. So if they ask any question from Thevenin's theorem or from maximum power transfer theorem, the first thing you need to do is to find both VTH and ZTH. Okay, so this is the circuit. This is minus 3j ohm and this is the open voltage VTH. Okay, so it means I removed the load, so the load became open, and so now this is the open voltage VTH. So I need to find the voltage across here. Okay, so the voltage across to find is very easy, right? So here what I'm going to do is that I'm going to assume this is, let this be I1, okay, and let this be I2. Okay, I2. So therefore if this is the open voltage, you don't need to assume that I3 is equal to 0. There's no use for that. It's much more easier is that this is open voltage VTH, right? Which means this is, if this is VTH, then means the voltage across this capacitor is also VTH. Okay, what is the impedance? Minus 3j. And what is the current? I2. So therefore VTH is equal to minus 3j into I2, right? VTH is equal to minus 3j into I2, right? That is the voltage, which means you just need to find the value of I2. If you found the value of I2, then you have found the value of VTH. That's what you need to do. Okay, so therefore VTH is equal to minus 3j into I2. Okay, so now I write the equation for mesh 1, that is equation for mesh 1. What is the equation for mesh 1? That is I1 into 3 plus 3j. 3 plus 3j minus I2 into 3j is equal to, what's the voltage source? The voltage is plus and this is minus, right? So therefore it is coming out from the positive term. This current I1 is coming out from the positive term, which means this positive terminal is generating I1, which means it is plus 5. Okay, 5 angle 0 is 5 itself. So that is the voltage. That's the equation for mesh 1. Now what about the equation for mesh 2? Equation for mesh 2. So over here minus I1 into 3j, right? Minus I1 into 3j plus I2 into, this is 3j plus 3 ohm minus 3j. See again, 3j plus 3 ohm minus 3j, which means this 3j and this minus 3j will cancel each other, so only this 3 will remain, right? This 3 ohm resistor will remain and there is no voltage source over here. This is equal to 0. These are the two. Out of this, just need to find the value of I2. If you found the value of I2, then you found the value of VTH. Okay, so how to find the value of I2 over here? What should I do over here? Here you can see there is here there is j, here there is no j, which means I will multiply this equation with j. Okay, if I multiply this equation with j, then I can add these two equations, right? So multiplying this equation with j, this will become j into j is minus 1, minus 1 minus becomes plus, so it is I1 into 3 and this will become plus I2 into 3j is equal to 0. Okay, so this is equation 1, this is equation 2, which means I'll just simply add equation 1 and 2. So adding equation 1 and equation 2. Okay, we get, so what do we get? That is I1 into 3 plus 3j minus I2 into 3j is equal to 5, and the other equation is I1 into 3 plus I2 into 3j is equal to 0. Okay, so if we add these two will get cancel each other, then you will have I1 into 3 plus 3j plus 3, which is 6 plus 3j is equal to 5, or in other words I1 is equal to 5 by 6 plus 3j. I1 is equal to 5 by 6 plus 3j. If I1, so you found the value of I1, which means I need to find the value of I2. What is the value of I2? You can use this equation, right? That is I2 into 3j. I2 into 3j is equal to minus I1 into 3, right? Or in other words, I2j is equal to minus I1. Or in other words, if I multiply into j and into j over here, then the into j over here, this will become minus I2 is equal to minus I1j, or I2 is equal to I1j. And what is I1? I1 is this one. So therefore I2 is equal to 5j by 6 plus 3j. This is the equation for I2. And VTH is equal to, VTH is minus 3j into I2, right? Minus 3j into I2 is VTH, and this is I2. So therefore this is equal to minus 3j into, and I2 is 5j by 6 plus 3j. So 3 into 5 is 15, j into j is minus, minus or minus becomes plus. So we have, this will become 15 by 6 plus 3j. 15 by 6 plus 3j is the VTH. Okay, that means, let me see, that is 15 divided by 6 plus 3j. 6 plus 15 divided by 6 plus 3j is 2 minus 1j, 2 minus j. So this is equal to 2 minus j. Okay, let me write over here. This is equal to 2 minus j. VTH is equal to 2 minus j. Okay, this is the equation for VTH. If you want, you can write it in the polar form also. That is, convert this to polar form. Let me see. You will get root 5 angle, or 2.236. 2.236 angle minus 26.565 degree. Okay, volt. This is the value of VTH. Now I found the value of VTH. Next I am going to find the value of ZTH. Okay, so to find ZTH, what you need to do is, ZTH is the impedance across this element, right? Impedance across this, and we need to short this. If you see any voltage source, you should short it. If you see the current source, you should open it. So here it's only voltage source over here, so you should short it. So that will be the circuit. So therefore the circuit is like this. That is, this voltage source will be removed. Then you'll be left with a resistor over here, which is 3 ohm. Then you'll be having an inductor over here, which is 3j. Okay, then you will be having another resistor and one capacitor over here, another resistor over here, and other capacitor over here. Okay, and the ZTH is the impedance across A and B, across the terminal A and B. This is 3 ohm and minus 3j. This is 3 ohm and this is minus 3j. Okay, so you need to find the equivalent impedance, right? That means this is the impedance means impedance across A and B. It means assuming that this is the input terminal, this current flows from A and it goes to B, goes through B. So what is the value? How do you find the value of ZTH? See, if you're having any confusion to how to find the value of ZTH, first you just simply try to find any two elements that are either in series with each other or either in parallel to each other. See, for example, okay, here I don't know anything about these elements. I don't know if they're in series or parallel. This is kind of giving me confusion. But just look at these two elements. These two elements. See, one end of the resistor is connected over here and the other end of the inductor is connected over here, which means both the resistor and the inductor have the same point. One end is the same point. Now look at the other end. The other end of the resistor is connected to the other end of the inductor, which means the other end of the resistor and the inductor is also having the same point. See, this is a single connection. In other words, this resistor and this inductor are in parallel. Okay, this is how I know it is parallel, because both the ends have the same point on both sides. Both the ends, that is this end as well as this end, has the same junction. See, this end of the resistor and this end of the inductor is having the same junction, same connection, and this end of the resistor and this end of the inductor is having the same connection, which means these two elements are in parallel to each other. Okay, this is how you need to find. In case if you're having any confusion on how to find the value of impedance, you start from one side, okay, and slowly you just need to either you add it up or you just need to do the parallel max in order to find the values. Okay, so here these two are in parallel, so you do the parallel calculation, right? So therefore, if these two are in parallel, which means the total impedance across for these two, when these two elements are combined, it will become 3 into 3j by 3 plus 3j, right? That is, this is nothing but 9j by 3 plus 3j, or in other words, this is nothing but 3j by 1 plus j, right? 3 by 1 plus j, or this is equal to, this is when 3 ohm is in parallel with 3j ohm. This is the equation, right? So therefore this is nothing but, let me see, 3j divided by 1 plus j. It is 1.5 plus 1.5j, 1.5 plus 1.5j. So which means now I have combined these two elements, right? So after combining these two elements, this now has become a single element like this. Okay, a single element, and the value of this element is 1.5 plus 1.5j. Okay, and the rest of them now I need to draw. The rest of them will be the same. That is a 3 ohm and a minus 3j. A 3 ohm and a minus 3j. Okay. So now I need to find next two elements that are either in parallel or in series. So if you look over here, look at this resistor and look at this this impedance over here, you can see that if a current flows through the resistor, right? If a current flows through the resistor, that same current will also flow through the impedance, which means these two elements are surely in series, right? Because if the current flows through this resistor, it's the same current that flows through this impedance. So therefore, these two are in series. So therefore, if they are in series, that means how do you add it? 3 plus 1.5 plus 1.5j, which is equal to 4.5 plus 1.5j is the total combination. So the next circuit will now become like this. This is minus 3j, and this impedance is getting after when you combine these two elements. So you got is 4.5 plus 1.5j. Okay, so now you found the value of this impedance. So now what you would do is that, now what is ZTH? Now ZTH is nothing but the parallel combination of these two elements, right? So therefore ZTH is equal to minus 3j into 4.5 plus 1.5j divided by minus 3j plus 4.5 plus 1.5j. This is the value of ZTH. Let me see. It means bracket, again bracket, minus 3j, okay, minus 3j, and we have 4.5 plus 1.5j. So 4.5 plus 1.5j. Close the bracket again, divided by bracket, and the denominator is minus 3j plus 4.5 plus 1.5j. So you get the answer as 1.8 minus 2.4j. This is the value of ZTH. So ZTH is equal to 1.8 minus 2.4j. This is the value of ZTH. Okay. If you want, you can let me find the polar form also. It is 3 angle minus 53.13 degrees ohms. This is the value of ZTH. So now if you want to find the value, now if I'm going to apply the Thevenin's equivalent. So from the circuit we have found the Thevenin's equivalent. That is, this is the voltage source and this is the impedance over here. Okay, and we have the load impedance, the value which we are trying to find. So we are trying to find the value of ZL. So this is the ZTH is equal to I will use this rectangular form, that is 1.8 minus 2.4j. Okay, this is the polar form, sorry, this is the rectangular form, and the value of VTH. Okay, I'll write both the values, okay, just in case. Minus 53.13 degrees, okay, and the value of VTH is over here, that is 2 minus j. It's equal to 2 minus j, or which is also equal to 2.236 angle minus 26.565 degrees. Okay, this is the value of VTH, this is the value of ZTH. So your job is to find the value of ZL so that maximum power will be transferred. So now, according to the maximum power transfer theorem, what is the value of ZL? You see, this ZL, they have not mentioned whether it is a variable resistance or whether it is a variable resistance with a variable reactance or a variable resistance with a fixed reactance. They haven't mentioned. So if they haven't mentioned it, you can assume that ZL is a variable resistance with a variable reactance. Okay, you can assume that both the resistor as well as the reactance are both variable in nature. So I am going to ask, if the load impedance is a variable resistance with a variable reactance, then what is the value of ZL so that maximum power can be transferred from here? According to your maximum power transfer theorem, if you refer the previous video, case 2, if you remember that, the maximum power transfer or maximum power can be transferred if the load impedance ZL is the complex conjugate of the source impedance. Here the source impedance is ZTH. That is what the maximum power transfer theorem is saying, that the maximum power can be transferred only if the load impedance is the complex conjugate of the source impedance. And we are assuming that because we are assuming that this load impedance is both having a variable resistance as well as a variable reactance. They haven't mentioned in the question what kind of a load impedance is this. If they have not mentioned what kind of a load impedance is this, then you can assume that it is having a load resistance with a load reactance, variable resistance with a variable reactance. So in that case, the value of ZL is ZTH star. Or in other words, ZL is equal to 1.8 plus, okay, it is instead of minus we have plus 2.4j. This is the value of the load impedance. This is the value of the load impedance in order to have maximum power to be transferred from the source to the load. Okay, so now the next question is, if this is the load impedance, then what is the value, what is the, they have also asked you to find the maximum power, right? So what is the equation for maximum power? We know that the equation for maximum power is given by P is equal to IL the whole square into RL, right? What is the value of RL? RL is the load resistor. Load resistor means the real part. What is the real part over here? This is the real part. This is the 1.8 ohm resistor, right? This real part means 1.8 ohm resistor, and this 2.4J means it can either be a capacitor or inductor or a combination of capacitor and inductor. It doesn't mind which one it is. So this is a resistor 1.8 ohm. So RL value is 1.8. So what is the value of IL? What is IL? IL is the current through the load impedance, or the current through this mesh. What is the current through this mesh? We all know that IL is the IL into ZTH plus ZL is equal to VTH, right? ZL plus ZTH plus ZL is equal to VTH. So what is ZTH is 1.8 minus 2.4J, and what is ZL? 1.8 plus 2.4J, which means this minus 2.4J and this plus 2.4J will cancel each other. You will have only 1.8 plus 1.8, which is 3.6. So you have IL into 3.6 is equal to, and what is VTH? This is VTH. Let me write this one. 2 minus J is VTH. So therefore IL is equal to 2 minus J by 3.6, which is equal to 2 minus J divided by 3.6, which is equal to 0.556 minus 0.278J. Okay, actually I don't need to find the IL. What I need to find is the magnitude of IL. What is the magnitude of IL? To find the magnitude of IL, simply take this polar form and you will get 0.621 angle minus 26.565 degree amperes, right? So this is the polar form, and if you want to find the magnitude of IL, this is the magnitude of IL. 0.621 is the magnitude of IL. Okay, or the other words how to find is that this is how you write this. A plus JB is also called as R angle theta. So therefore in that case R is equal to root of A square plus B square. Just simply you can find, if you want, you can simply find that. So root of 0.556 the whole square plus 0.278 the whole square. If you apply that, root of 0.556 the whole square plus 0.278 the whole square, you will definitely get 0.621. So this is the magnitude. IL is the, this 0.621 is the magnitude. So therefore the value of power is given by P is equal to magnitude of IL the whole square into RL, which is equal to, that is magnitude of IL is 0.621. So therefore it is 0.621 the whole square into, and what is RL? RL is, this is the RL, right? The real part of the complex number of the complex impedance is the resistance, is the resistor. So it is 1.8 into 1.8. This is the value. Okay, let me see. 0.621 the whole square into 1.8 is equal to 0.694. Therefore P is equal to, or the power is equal to 0.694 watts. This is the value of the maximum power. Okay.